Hello guys, welcome to lesson 7 of Fusion. Last week, in the last lesson, we talked about some of the new features that Fusion is starting to feature in the tabs, and one of them was insert fasteners. So when you try to insert a fastener, Fusion gives you three options for now. You get bolts and screws, nuts and washers. So when you select a bolt of some kind or a screw of some kind, you can find different ones from the available sets, and you can just drop them into your design. Okay. And we did some examples on the last video. Today we're going to talk about something that's been in Fusion for a long time, and that's the McMaster Car components. Now, McMaster Car is an American hardware company. They stock a lot of different hardware, and when you click on it, you'll get a menu as such. Now, the important part of this company, it's that many of the items that it sells has 3D models that you can use. And we'll do an example. Something like, let's say you're working on a product and you need some bearings in this product. You can go into their bearing catalog, select the type of bearing, and for this example, we'll select the simple ball bearing. Okay. You can put in the dimensions that you require. Let's say we'll have something with a 10 millimeter inner diameter. Okay. Let's select the outside diameter. Let's say something like 22. It's a ball bearing. Okay. And as you can see, the right side is changing according to what I select on what I filter on the left side. So I'm getting these options. If I want to make it even more detailed, I can keep selecting. I want steel. I want a single row bearing. Let's see what I get. Okay, I'm down to 3 options, and a permanently lubricated ball bearing. Let's say I'm going to select this one. Okay. And as soon as I select that, a menu opens up. It's asking me which type of CAD I would like this for. Now for Fusion, we always select step, okay? And then we can download it. And when I press download, Fusion gets this file from McMaster Car and puts it in my design. I can manipulate it if I need to place it somewhere. Let's say I'll do that for now and say, okay. Now, because I manipulated it, I'm getting this capture position thing, and I'm going to say, yeah, capture the position of this. Okay, now this bearing has all the dimensions correctly applied according to my selection. And that means I don't have to model each and every hardware that I'm using in my designs. This makes it very easy to implement ready-made hardware that you can buy at a hardware store into your designs. And these models are pretty good in terms of their design features. Let's say I'm going to cut this model, and I'm going to use the section analysis for that. Okay, I'm going to press section analysis. I'm going to select the cut plane, something like that. Then I'm going to move my cut plane. Okay. And I'm going to select OK. Okay. Now I can see the inside of the object. I didn't actually cut the object. It's giving me a preview of what the inside looks like. And as you guys can see, it's pretty detailed. Okay. So they are also usable for renderings if you need to. And when I want to get rid of this section view, I can go into analysis, and I can unselect my section view. Okay. I can change this section view. I can change my plane. Okay, I can turn my plane, my cut plane, and look at it from the center. I can move my cut plane. Okay, like that. So if I want to look at any of my components or bodies in a section view, I can do this. And when I want to return back to the normal view, I can go and deselect my section or my analysis. Okay. So you can use a lot of different McMaster car components in your designs, especially screws, nuts, washers, and everything, even springs that you don't have to model. You can write it in the search box to see if it's available. Let's say I'm gonna use a spring. Let's make this a little bit bigger. Okay. Let's say I want to use a compression spring. I want it to be metric in size. The length, I want a 6mm spring. I'm gonna get two options. Okay. The only difference between them is the wire diameter, which changes the force, of course. I'm gonna select the thicker one, and step is selected. I'm gonna say download. Okay, so I get my spring. So I don't have to model this. Sometimes you will need to model items as such, but if it's available in McMaster Car, makes it that much easier. Okay, so that's my spring. So now you know how to integrate hardware. Now the main difference between McMaster Car and the insert fasteners is the fasteners are generated by Fusion. So the placement feature is very, very good. If you have multiple holes, you can, and if you just want to use washers, nuts, or bolts, I would suggest using insert fasteners. But if you need anything else that might be sold at a hardware store, I would definitely try McMaster Car. Now there's a third option called TracePart. Now TracePart is a very large community of manufacturers that upload models into a company called TraceParts. And when you're using items that are more than hardware, like electronic components or different types of electrical connectors, or even linear rails or other products, you can search for it in TraceParts. You can say, let's say I want a connector, IEC type connector. This is the connector that you can find on your home computers, for example, or electronic devices. And you can select this. Now, the problem with TraceParts is it doesn't always work. So you can see my CAD model is selected as Fusion 360. And if you're doing this for the first time, you have to register on TraceParts, which is relatively easy. But let's say you did register and you come to this screen, you select your CAD type, and when you select download, it should download, but most of the time you might get this. This is because TraceParts is trying to catch up to Fusion versions, and sometimes you get caught in the middle where TraceParts hasn't updated its system. But this usually gets solved in a few days. But as you can see, the 3D model, which you can download, okay? So if you have complex stuff manufactured by certain manufacturers, you can also use TraceParts, of course, when it's working. Now, if it doesn't work in Fusion, what you can do is you can go into the TraceParts website, okay, and download it from there. which is also an option. You don't have to do it inside of Fusion. Once you register with TraceParts, you can go and do that as well. And I'll show you that now. So I'm at the TraceParts website. It's traceparts.com. What I have to do is I have to sign in. Okay. Let's see if my password is working. Okay. Now let's do the same search here. Connector IEC. Okay, so I get my connectors here. This is actually sometimes it's actually a better way to do it because you also have filters on the left side, which you don't get in Fusion. Let's select the same part or similar part. So I have it here. I can go and select my CAD type. Okay, Fusion 360, and I can say download. Okay, your request is being processed, preparing the file, and as you can see on the right hand side, I get an activity window, and I click download. It's asking me to open it in Fusion. I usually select this, okay, and open it as Fusion, okay, and there's my part. Okay, as you can see, it's a pretty detailed model that you can use in your designs. Okay. Now, I'm going to show you guys something else that you might actually need from time to time. We're back at the web browser. Now, there's a site called health.autodesk.com. Okay. Now, when you go into health.autodesk.com, what you see is the status of all of the products that Autodesk provides in terms of cloud computing. Okay, so Fusion is, as you guys have realized, I hope, has a very connected system with the cloud. So whenever you save something, it's uploaded into the cloud. Of course, you can use Fusion offline, but the advantage of having it cloud-based is you can go into any computer, load up Fusion, and access your parts. Okay, but sometimes you will realize that it's not working for some reason. Okay, so if it's not working, the first thing that I do is I go to health.autodesk.com and check the status. As you can see, there are 4 different statuses: operational, degraded performance, outage, and maintenance. And I check how Fusion is doing. Okay, so I scroll down and look at how Fusion is doing. Okay, now if there is a problem, if the check mark isn't green, that might be a problem at the Fusion servers, Autodesk Fusion servers, or there might be an update, and it's usually solved in minutes, but sometimes it can take up to a couple of days. So don't get worried about it. Just check this. And if everything here shows green, it might be a problem with your side. It might be a problem with your computer, or you haven't updated Fusion. Okay. Okay, so just, keep this in mind. Okay, let's go back to Fusion. So this is how we use McMaster Car and TraceParts. Okay, you can use these. I use them very, very often when I'm doing designs. I don't have to model everything. These parts come in as components, as you can see on the left-hand side, and I usually rename them according to what I need to remember. Okay, something like that. Ball bearing. This would be a spring, for example, and a connector. Okay. So Now you know. Okay, let's close this. I'm safe. Okay. Now, a new design and a new feature. We're going to talk about a new feature now. I'm going to create a cylinder. Okay, a primitive, just as an example, so it makes it easier. Okay. Now I have a cylinder. Let's say this is my product. Okay. Most of the time, what you will see on products are markings or stickers or anything that is needed to create a brand or some kind of information that should be on the product. And Fusion has a nice way to do that. It's called decals. A decal is usually referred to a sticker or any kind of marking that is on the product, okay? And to use a decal, you need one of three types of image formats. It has to be a PNG, JPEG, or a TIFF. Now, I would advise you guys to use PNG because of the size and the quality of the alpha channel. Now, what is the alpha channel? Let's insert a PNG. Okay. Let's say this is my logo, and I'm going to put it on my product. So I click a face, and Fusion puts it on that face. Okay. But the original picture has a border around it. Let's see if I can show you guys that. Okay. So this is the original picture. You can see it has a white border around it. But when I change this to a PNG, I can get rid of this border and use it as an alpha channel, which means a channel that I can control the opacity. Okay? So I have an alpha channel on this image, and I can only see the bird, which is great. So I move it to the place that I want. I rotate it. Let's say this is my brand logo. Okay? I can resize it. Okay? And the nice thing is, when I bring it to the edge of my product, Fusion adapts it so it actually moves on to the top face, as you guys can see. Okay? Right? It has a nice feature that it makes it adaptable to the surface. But for this example, I'm going to have it on the side. I'm going to say OK. So I have my branding logo on the surface of my product. Okay. Now let's change the color of my product. So I right-click my product, my component, select appearance, and I'm going to select a plastic case for my product. So I go into plastics under Fusion appearances. You can see I have different types of plastic here. I'm going to use nylon. But as you can see, there's a red dot. That means this file isn't available locally, so I press download. It's downloaded. I bring it up to my design, and I apply it. Okay. So now I have my product, whatever that is. Okay, so that's how you apply a decal. You can always move it after the fact. Let's say I go and right-click my decal. I say Edit Decal. And I can resize it. Okay, I can mirror it, of course. I can make it smaller. Yeah, let's say I want it here. Or let's say I want it on the top face. I can just move it to the top face. And yeah, that's it. Okay. So that's a decal. We're going to delete the decal for now. Okay. Let's go into another insert function, which is the insert SVG. Now, SVG is an open type vector format. And we can use this as... Oh no, I wasn't going to insert that. Okay, let's cancel that. I want to insert something else. I want to insert a logo. Let's say another type of logo of one of my companies. Okay, let's say this one. So Because it's a vector format, it's very similar to using lines and arcs, even splines sometimes, okay? So just like the decal, I can move this, I can resize this, okay? And because it's not an image, unlike the PNG or JPEG or the TIFF from the decal, this is not an image, it's a vector format. So it's a mathematical formula, basically. That means when I resize it, I don't get any problems with my resolution, okay? So this is, let's say I want to apply this on my product. Okay, I say OK. Now you can see, let's hide my product so you can see it better. Okay, you can see that I have imported it and it's green, okay? Now, if you guys remember, green means fixed, okay? So this came in as fixed. And if I want to manipulate this in terms of getting rid of some of the lines or move it, let's say, let's finish sketch. You have to finish sketch once, then go back and edit sketch. Let's say I wanna change some stuff. You see, I can't pull it, I can't modify it. But if I unfix it, okay, you can see I can go over the lines and click them and unfix them, okay? If I unfix it, it will be available for modification, okay? So when you unfix it, you can move it. So I can do some changes because it's a vector. It's acting like a sketch line in Fusion. So I changed that. And I'm going to get rid of some of the lines here, which I don't need for my product. I'm trimming them. I don't need these. I don't need this. I don't need the inside here. And I don't need these. Okay, get rid of these. I have something left here. Okay, do I have anything left here? Yeah. Let's get rid of these. So I'm cleaning up the SVG that I pulled in. Okay. Okay. If you can't select it with a mouse click, you can always drag the trim. Okay. You get this icon. You can drag it and it'll clean stuff that's under it. So that's, I have my logo, a clean logo, okay? I say finish sketch. I can view my body now, my product, and I can use this, okay, SVG, as an item for embossing. I can use it as an extrusion on my product. Let's say something like that. Okay, so I have my logo on my product. Okay. You can also use this as an emboss as well, let's say on the side of your product. So that's how you import an SVG. Let's delete these. Let's do the same thing with the DXF. Now, a DXF is a much older format. Currently, it was, I believe it was found by Autodesk at the time, but it's now an open format. Let's insert the DXF. We have our plane selected. Let's select the file. Okay. Select it from my computer. Select the bird. Or no, the bird is big. It's a big file. Let's select something else. Okay, let's select the same thing, but in a DXF format. Okay. Now, as you can see, where is it at? It's right there. Okay, so let's move it to somewhere like there. You can see that I don't have as many controls as I have on the SVG because the sizing information, the scale information, and all of that is included in the DXF, so it comes already at a certain size that it was defined in DXF. Doesn't matter for example. Let's say OK. So I have my imported DXF. As you can see, it looks like a sketch. And unlike the SVG, because it has its size information included in the file, it's not fixed, okay? So I can edit it just like the SVG. I can clean it up just like the SVG file. Usually a DXF is cleaner than an SVG file, but there are times where I use both. Sometimes you can find stuff as SVG, sometimes you can find it as DXF. It doesn't really matter for our purposes. Okay. Finish sketch. Now I can use this DXF file to, say, export my logo. Okay. That's what it looks like when you insert stuff. Now, the rest are a little bit advanced, so we're not going to get into that. But now you know how you can use external references in your models, either by using them as decals or using them as bodies or components. Okay, let's take a break. Okay, so now we're going to get into a new topic. So let's close this. Now we're going to talk about the second tab for the rest of the lesson. Now this tab is about surfaces. Now in Fusion, solids and surfaces are very close in terms of their capabilities. However, surfaces do offer some differences in terms of creating a model, and it has some interesting interactions with solids. So the way you model with surfaces is very similar to how you model with a solid. So I'm going to start with a sketch. On the top plane, I'm going to create a square, and this time I'm going to go into surfaces and I'm going to create a surface extrude. Okay, so this is a surface extrude. As you can see, only the lines are extruded, and these would be considered two-dimensional objects, two-dimensional surfaces, as they don't actually have a thickness. Okay, so if I was trying to create a box with surfaces, what I would do is I would do something similar to what I did here. Then I would try to close the top and the bottom. Now, the way you do that in surfaces is after you extrude, you select what's called a patch. Okay, a patch is used to close openings in surfaces. As you can see, I selected the topmost edge, and because enable chaining is selected, it selected the chain, the contour that was chained to the line that I was selected. So you can see these four edges, and it's showing them here. And I can say OK, and now you can see under bodies we have two surface groups. Okay, just like the solid bodies, these are the surface bodies that we have, and the first one that it's showing here is the top surface, and the second one is the first extrusion that I did. Okay, so now you can tell, because we have two surfaces bodies, that these are not connected, and we're going to get to that. Now I'm going to do a patch on the bottom as well, patch the bottom, say OK. Now I have free surface groups. I have my extrusion, the top and the bottom patch. Now, when working with surfaces, to do complex features, you have to stitch them. Okay, stitching means, just as the name suggests, connecting surface groups. So I'm going to select I'm going to select it from here. I'm going to select the extrusion, then the top patch, then the bottom patch. And you will see that in my stitch dialog, I have something called the tolerance. Now, the tolerance is the gap between my surfaces that are going to be stitched. So if this tolerance is too low, I might not be able to stitch some surfaces that are more complex. But in this example, I don't have that problem because the surfaces are pretty geometric. And what I'm going to do is I'm going to say OK. As soon as I say OK, because all of these surfaces are stitched, it leaves being a surface and turns into a solid. Okay, as you can see, it's a solid. Now, I'm going to undo this. I'm going to undo, go before the stitch. I'm going to select section analysis. I'm going to select this space. I'm going to move my cut plane to somewhere around there. Okay, now you can see it's empty on the inside. And I'm going to stitch it, and you can see the transition there. I'm going to re-stitch all of these. I'm going to say OK, and as soon as I say OK, you see the inside is filled. It turned into a solid. Okay, so the nice thing in Fusion is you can turn surface models into solids when you have all of the touching surfaces stitched. Okay, and you don't have any gaps. So I'm going to unstitch it. I'm going to close my analysis. Okay, so I have these free surface bodies. Now I'm going to delete my top and bottom patch. Oops. Delete the top patch. Okay. Now, there are other things that you can do with surfaces which are pretty interesting. We talked about extrude and patch. These are the most simple ones. Then you have something called a ruled surface, okay? A ruled surface. Now, a ruled surface is very similar to an extrusion, but you can use it to do angles, okay? So you have the ability to do angles. So you can open it up, basically control your extrusion with the surfaces. Now, there's this single thing that you have to watch out with ruled surfaces is the type of ruled surface that you're working with. Now, if you select normal, okay, the ruled surface will try to match the normals of a surface, and the normals of a surface are always perpendicular with where it's starting. Okay, so this surface is trying to match the normals with the bottom surface because it's starting from there. Now, if you select tangent, it will try to create a tangency. Now, in this example, they don't mean much, so we're going to do another example that it will mean more to you guys. And then we have the direction, okay? The direction. Now, the direction, as you can see, it's not giving us any type of model, okay? Because the direction in this example will be very similar to, it will be exactly like an extrusion. So instead of using a direction in this example, you would use an extrusion. But if, let's say, if you had another type of direction where you could select it, okay, then it would mean something, okay? But you can use it like a taper, which is sometimes useful, or what you can do, and I'll do this example for the direction. Let's say I have a specific direction that I want. I have to tell Fusion what that direction is. So what I'm going to do is I'm going to create a direction sketch. I'm going to create a sketch on the side of the box. I'm going to select the line, and I'm going to say I want it to be this direction. So this is going to be my direction line. I'm going to finish the sketch. I'm going to go to ruled surface. I'm going to select it. I'm going to select direction. Then for the direction, I'm going to select this, okay? So I can do this with direction, okay? Once I give it a direction line that is different than a continued extrusion, let's say, I can do this type of stuff, okay? So this is an example where it's different from solid modeling, okay? This is very similar to a sweep in some aspects, but it's only a single vector. You can't do complex vectors. You do that with sweep. Okay? Now I can open this up in this direction. Okay? You have to be aware that it will break up the top, but the side lines will be fine. Okay? Let's say I wanted to do something like this where it opens up, okay? It opens up in the direction. I say, okay. What I can do is I can patch this surface, okay, and close it. But it's not going to give a nice surface. As you can see, it's being broken. So what I can do is I can create a surface. I can create a surface. And to do that, I'm going to show you guys something new. I'm going to show you guys something called a 3D sketch. Okay? When you select sketch, okay, and select the plane, it doesn't matter which plane it is in a 3D sketch. I'm going to select this one. Okay? You have this option down below, this check mark. Okay? Now, once you click this, you're in the 3D sketch environment. This means you can sketch anywhere, but you need relations. So I'm going to be sketching on this form. I'm going to go from this point and create a line to this point, okay? So I have this line, okay? And I'm going to say finish sketch. So I have the sketch that is angled, but it's connecting this. The reason that I did this is I want to create a plane using a patch. So I'm going to select patch. I'm going to get rid of enable chaining, and I'm going to select the edges. Okay. And as soon as I finish my closed contour, it's giving me a patch. As you can see, I hope. It's closed this part off. Okay. I can say OK. And I can continue doing this. I can, let's say, I create another 3D sketch. I can sketch on this plane. It doesn't matter for me for now. I can say, let's create a line from this edge to this edge. Finish sketch. Let's patch this surface up. Okay. So I have a patch surface here, and I'm going to patch the middle surface as well. I'm going to say, use these. Okay. Now I have a patched surface. You might have realized that the color that we're seeing here, this golden color, is different than the gray. The reason for that is Fusion gives the negative side of surfaces this golden color, and the positive side, this gray color. So what I need to do to have a successful model, especially when I export it to other programs, for example, to turn the normals of this surface. So I have to reverse the normals of this surface. What I do is I go into modify, I select reverse normal, I select the faces that I want the normals reversed, these 3 patches. I select OK. So you can see it's gray now. And if I look at the inside of the object, you will see that all the negative sides are golden. Okay? So I have this. And you can see I have 5 surface bodies now. What I can do is I can stitch the top free. I can do this, say okay. Now I have 3 surface bodies, and this has just become a free, from 3 bodies to a single body. Okay, and if I close the bottom now, I will turn it into a solid. Okay, but I don't want to do that for now. I'm going to show you guys how to cut this so it's straight. So if I go into modify, there's this thing called split face. Okay, I select it. I want to split these faces. Okay, I want to split these faces, and I want to use this tool to split it. But currently it doesn't reach those surfaces. As you can see, it's on the top, so I have to select extend splitting tool. It says, if I extend this, you can see it, it says extend splitting tool, and I say okay. You can see it created a line. Okay, and I can delete these now. I can say, I can select the body and delete it. If I just close it, you will see that they're still there. So I have to delete them. Let's say I delete these surfaces. I just select them and press delete on my keyboard. I can right click it and press delete as well. Now the nice thing about deleting it this way is it's in my history. As you guys can see, if you look down below, you can see all the deleted surfaces in my history. Now I have a clean directional ruled surface, and I can create a patch. Okay, I can create a patch to close this surface. That looks like a kiosk at shopping malls, right? Okay, so I have that. So now you know how to do an extrusion, a patch, a ruled surface, and you know how to stitch and reverse normals and split face. So these are pretty basic tools. You should get used to using them. Now one thing that I want to go back now to the ruled surface. I'm going to go all the way back to here, delete all of these, okay, delete this patch as well, delete my 3-dimensional sketch, and edit my ruled surface. So one thing you might realize is these edges are turning into cones, okay, they're getting softer. If you don't want this, you should select mitered corners. Okay, if you select mitered corners, they will continue as sharp edges. But if you have unmitered corners, they will turn into cones, so they will soften up. Okay. Sometimes it's useful this way. So Fusion has this option. Okay. You will see under operations there is no join. So that's why we use stitch. You can't join one surface to another in ruled surfaces. So you need to use stitch after you create your 2 bodies. You have to use stitch to join. Okay. So there's a single surface body. Okay. Okay, so that's how you would control a ruled surface. Now, another link between surfaces and solids is by using this option called thicken. Now, you can create surfaces, and if the shape allows you to do, you can select your shape and create a thickness. Okay, now if your shape doesn't allow you to create a thickness as a whole, you will see it once you create a thickness. You can see cannot offset selected face. Okay. And what we can do for this is we can cancel this thicken, and we can arrange our shape to be a smooth surface. And we can use that. We can do that by doing some changes. And let's do that. Let's get rid of this. Let's change this, and let's get mitered corners so we can do our own fillets. Okay. If you go into modify, you can select fillet. You can create fillets on surfaces. Let's create a fillet, a little fillet, something like that. Okay. And say okay. Now let's create a fillet on the outside edges. Okay, so let's give it a 5mm, something like that. Okay, so now we have fillets on all sides. Now let's try to thicken it now. Select thicken. Okay, give it a 5mm thickness, and as soon as I say OK to the thickness command, it turned into a solid. Now if I hide this solid and reopen my surface, you can see the surface is still there, so you can modify it, and that will change the solid that the surface turned into. So you can use the thicken command like this, and you can keep modifying it. You can do internal fillets to this if you desire. So you can create, that's another way you can create solids from surfaces, by using the thicken command. Okay, and you can experiment with this. You can do your thickness towards the outside. Okay, for example, something like that. It's computing the thickness. Sometimes this might take a minute or two, depending on the complexity of your model. Okay, sometimes this might give an error as well. Usually if it previews, it doesn't give an error, but sometimes it might. Let's see what's going to happen. So this is real time. I'm not cutting the video. Wonder if it's going to do it. Who knows? Now this isn't about your computer performance, by the way, so don't worry if you're waiting for this. It's not because your computer might be slow. It's about how Fusion calculates stuff. So even if you have a very fast computer, it doesn't matter. It's going to take a while if it's doing a complex thickness. Okay. think I'll actually stop the video until this finishes so we don't get too much uploaded data into YouTube. So it took about 1 more minute, but that's what it looks like. Okay, so you have a thickened, interesting part. Okay, now let's go back to before we stitched. Okay, so now with surfaces, you have some other options that you don't have with solids. You have this thing called an extend, and the extend gives you the ability to extend any surface according to its shape. Now I'm going to select this edge, for example, and I'm going to extend. Okay. Now you can see it's extending in a manner where it's getting closer, the lines are getting closer, and that's the natural type. Okay, if I select the perpendicular type, it's going to extend 90 degrees to that surface, and if I select tangent, okay, it might give me an error like it does here because there is no tangency. Okay, now let's select natural, and instead of selecting free edges, I'll say align edges, so it keeps going the same shape. It extends the shape as the lines are progressing towards the infinite. Okay, so that's the difference between free edges and align edges. Now we're going to do examples for the tangent as well. Okay, let's cancel this. Let's open up a new design. Let's select sketch, and let's select let's sketch on the top surface using a spline. Something like that. Okay, and let's go into surface, and let's create a sweep, or actually let's create a loft first. So on top of this plane, on the top plane, I'm going to create another plane, and I'm going to sketch on that plane another spline. And what I'm going to try and do, and this is good practice, is have the same number of points even if the shape is different. I'm going to try and have the same number of points. Okay, so the shape is a little bit different. Okay, I'm not sure I like that. Yeah, let's do something like that. Okay, so I have equal number of points, and I'm going to create a surface loft. Just like in the solid, I'm going to select both of my closed contours and select OK. So I have a surface loft. Now, if I wanted to have an empty, like a pipe, I can use the thicken command, and I can use this as, it looks like a bone actually. I can use this, or I can keep extending this. For example, I can keep extending this, and Fusion does some calculations about how the surface would go. Okay, so that's in the natural state. Okay, I can go into tangent, which has only can do it this much because of the tangents between surfaces gets complicated after this, and we get an error after 85 millimeters because of this edge. You can see it's folding onto itself. You can see it here. Okay, this is creating a problem, but the natural seems to work. Okay, and this will also have a problem in the future, maybe when it intersects. If if I keep going, yeah, it's around 27 or somewhere around 31. It doesn't work after that because of the shape of my loft. But you can extend in this manner. If you have aligned edges, it will not change anything because the edges are on a flat plane because of the sketch. Okay, so that's the way you can use the extend tool. It's very useful in surfaces. I can patch this. Okay, I can patch this. And I can patch the bottom, just like the example before. I would like to reverse the normal on the top patch, and I can stitch these free surfaces and get a solid body, okay, which I can manipulate with the solid modeling tools afterwards. Now, there's this interesting thing in surfaces called an offset surface, which is very useful. It's this icon. It's under Create Offset as well. And the offset surface creates a surface with a selected distance between the original surface. So I have a single surface here. I'm going to select this surface and I'm going to offset it. I can only offset it this much, which is fine for example. In this shape, I can only offset it 20 millimeters. You can see that it has created an offset surface from the body, from the solid. Okay. Now, if I go back, if I delete all of this, go back to my original loft, I can also offset from a surface. Okay. So I can also offset from a surface. And now what I can do is I can create a patch between these two surfaces, right? So see, there's this little problem there because the surface gets under that one, but it's not a big deal. I can cut that afterwards. I can do this. Actually, I'll give you an example of that, which is a very useful way to create interesting shapes. What I'll do is I'll patch the top surface, okay? And I'll patch the bottom surface. Okay. I'll reverse the normal on the bottom one. Okay. Now I have this closed shape, which I haven't stitched yet on the outside. And these are those. I've hidden those. And I have this internal one. But if I want to cut this top patch, the inside, and if I want to use the inside tool as my cutting tool, I have to go through the top surface. And what I can do is I can hide these, right? And I can extend my surface a little bit on the top, and I can extend my surface a little bit on the bottom. And when I unhide these, you can see that I'm going through those surfaces now. Now what I'm going to do is I'm going to select the cutting tool, and that's the trim. What I'm going to do is I'm going to select my trimming tool, and after that I'm going to select the surface that I want to get rid of, which is this part. It turns a shade of red, and this part. Okay, I'm going to select OK, and you can see that the inside of the top and bottom patch are deleted. Okay, what I'm also going to do is I'm going to use this patch now to cut my inside shape. So what I'm going to do is I'm going to select trim. This time select the patch as my trimming tool. Then I'm going to select this part, cut that. Okay, you can see it's clean now. And do the same on the bottom. Select my patch, then select this part, cut, and reverse to normal on the inside one, because that's going to be an outside after I stitch them. Okay, so now I have these tools. Now I want to stitch them to turn it into a solid. Select all my surfaces, select OK, and I have a solid body. Okay, I have a solid body, and I can check the solidness of my body with a section analysis tool. As you can see, it's a solid body. Cancel. Okay. Now, even here, even with this, I might want to offset this, for example, like that, and create something else on top. Let's say I'll extend this. Where's my offset? I'll choose this. I'll hide my body. Okay. I'll extend this. I can only go this far. Okay, for example. Now I can have a section that is separated and continue from there. So it's like, let's say the spline of a human. I can make this middle part my joints, for example. And you can create many different things with this. Okay, if I want to press and pull on this surface as a solid, I can only do up to a certain point, because this surface is very complex and Fusion is having a very hard time calculating that, but you can only do up to a certain point. But with surfaces, you have many more options. Let's cancel this, and let's try that with the loft, for example. Okay, let's go back to our loft, our original loft, delete these. Okay, let's edit the loft. Okay, now let's say I want to have something like a direction on both of these. Okay, so I have a direction which is starting according to how I control it. Okay, let's say something like that on the top, and on the bottom, and on the top it's something like that. Okay, so it's bulging towards the top, and the bottom is coming out from a tangent. Let's say looks like a weird tooth. And if I wanted to extend this as a tangent, okay, you can see I can do this much before this edge gets very wrinkled. But in the natural way, I can do it up to here, okay? And this is getting very wrinkled. Now, you might be having a hard time understanding this wrinkling. And for that, we have a tool. And this tool, you need a little bit of experience to understand what it's showing you. But I'm gonna show you that tool so you can start experimenting with it. It's called the zebra analysis, okay? Now, when I select the surface, when I select zebra analysis, then select the surface, you're gonna see these lines moving on the surface. And anytime you get to a junction point, you will see how the surface flows, okay? Now you can see from this line over here, for example, this white part, that these surfaces are meeting up very clearly. okay? And if you look at the top line, it's going up, then it's going down like that. You'll see that there is a separation, and the lines, the zebra lines, aren't flowing, okay? So this is a very good way to check the continuity of your surface, okay? If you look at, for example, this side, and I can make this high quality, by the way, it's easier sometimes. You can see that this part we don't have a problem with. The lines are flowing nicely, but once you get to this line, you can see that there's a breaking point. You see this line here? There's a breaking point at this line, and the curves aren't flowing smoothly. Now, the problem this will create will most likely appear when you're doing extend surfaces or when you're doing renderings, okay? Look at what's happening here. The line isn't flowing, and we're getting a bulging line here. And at this wrinkle point, look at the concentration of zebra lines. Look at this concentration here. It's too much, okay? Actually, when you look at it like this, you can see the breaking point right there. So with the zebra analysis tool, you can look at the flow of the lines on your model. Let's cancel this for now. Okay. Now, let's create a loft. Okay. Let's get rid of this. And let's get rid of this. Let's create a sweep, I mean. The sweep is very similar to what we do in solid modeling environment. Actually, let's remove this 3D sketch for now. Let's say finish. And on the right plane, let's create a spline. No, not that spline. The fit point spline. Okay, let's do something like that and that. Okay, and whoop, that's the wrong plane. We drew on the wrong plane. Okay, let's start a sketch and draw on this plane. Okay, select spline. Let's do something like that. And before I finish the spline, I'm going to make sure that I'm leaving the circle on a almost tangent, or let's say perpendicular angle to my circle. Okay, let's actually arrange it like that and that, so it looks like a table lamp, for example. Something like that. Okay. Now let's create a sweep with the surface. It's very similar to the solid sweep. I choose my profile, then I choose my path. Okay? But it is a surface. So you have all the surface tools available to you. So you can use extend to extend it. Let's say tangent. Okay. As you can see, the natural on this one doesn't work, unlike the rectangle as my example. The perpendicular will work. Okay. And the tangent is the right one for this, because you want to keep the tangency flowing. Okay. Now I'm going to select tangent. Then I'm going to look at my bodies. I have a single body because I extended it. Then I'm going to look at my zebra analysis. Okay, let's see how good it's flowing. Now there is some. Let's select the high quality. There is some offset. Okay, it's not super clean, but it's usable. This part I don't like, this transition. It's not that good, but it's usable for our purposes. Okay. You can see this jaggedness. You can see this jaggedness, the lines aren't flowing, but for our purposes, it's fine. Okay. So you can use extend there. You can use extend on the bottom as well. Okay. And you can use ruled surfaces. Okay. Let's select normal. Something like that, for example. And then do a fillet, maybe. But before I do that, I have to stitch them. Okay, let's do a fillet here. Okay, something like that. Okay, that looks okay. Now let's look at the zebra lines. What's happening here? Okay. There's some breaking here. It's not too bad. See, even though it's breaking, you don't see any jaggedness. The lines are meeting, unlike here where the lines aren't meeting. Okay. Or here. Okay. So that's what it looks like. Let's hide the analysis for now. And then we can use this, let's say, as a pipe. We can use this as a pipe, okay? And what we do there is we thicken, okay? It's like creating a saxophone. So that's how you would do that. Okay. So that's the sweep. And basically, extrude and revolve are very similar to the solid. The sweep, the loft, is also very similar to the solid. So you have these free tools, the patch, the ruled, and the offset that is different, which you don't have in the solid environment. But the offset is also useful in the solid environment. And in this example, because I thickened it, it turned into a solid, right? I can use the offset to create an external offset of a certain area. I have to uncheck chain selection. Let's say I can offset this surface. Okay. And offset it again. Something like that. And then patch it. Okay. I don't have to patch the inside actually. Let's cancel that. I only have to patch the outside here. Okay. Okay. And patch this and create a solid, or instead of doing that, if I know what I want to do, I can just go into, actually let's delete this second offset. After I create this, I can say thicken. Okay. And try to thicken this. Something like 10 millimeters. Okay. Okay, so I have an interesting shape, and I can keep doing this and create interesting stuff. For example, then I can link these two, for example, do different things. And the surface modeling allows you to do this very simply and very fast. Okay, now let's get into some other commands in the surface environment. Don't save this. Okay, and to do that, I'm going to do a sketch. I'm going to create a basic rectangle. I'm going to create a patch surface, just a patch surface. Then what I'm going to do is I'm going to create a circle on that patch surface sketch, and I'm going to extrude that. Extrude this, and I'm going to extrude it symmetrically, so it's extruding towards the top and the bottom. Okay, as you can see. Then I'm going to trim this. Let's open up our bodies view so you can see we have two surface bodies, and I'm going to trim it. I'm going to use this tool as the trimming tool, and I'm going to get rid of this. Okay, let's hide this. Okay, so I have my patch with a circular opening on top. Now you might have, even though this is a basic example, you might do this for some reason, and you might have trimmed something, but you want to get rid of it. You want to close this. Now there's this another command called untrim, and the untrim allows you to get rid of the trimmings on your surfaces. Okay, as you can see, as soon as I select the face, select all the edges, I can say manual as well. Okay, I can say manual and then go and select it, or I can leave all edges and it does the selection by itself. There's this internal edges example. It does the stuff on the internal and the external. And actually, let's do that. Let's do a cut on the external as well. Let's go back to our sketch. Let's create something right there. Finish our sketch. Do an extrusion for that one as well. Okay, and trim using that one as well. Okay, let's hide that. So this is my external edge, and this is my internal edge. So if I say untrim external edges and select my face, it will correct the external edge, and if I select only internal edges, it will correct the internal edge. Let's say all edges and say OK. Now if I say keep a copy, it will duplicate. It will duplicate. Let's do that. Keep a copy. So I have my fixed face and the face that I have after the trimming. So that's what keep copy does. It creates another one in its fixed state. Edit feature. Okay. Now, as you can see, the keep copy is gone. Okay, so you only do that once. If you don't want to keep copy, you have to go back and delete it. Okay. Okay. No, not that one. Okay, so this is what we have, and that's what untrim does. So you can trim, untrim, you can extend, stitch, and now let's do unstitch. Unstitch is very simple, and we're going to do it by extruding this. So we extruded this external contour, and we're going to hide, no, not that one, this bottom one. Now it's showing us a single surface body, but we know that we have multiple surfaces. Okay, so if we say unstitch and select our faces and bodies and click OK, you'll get every one of these surfaces as a separate surface. What this will allow you to do is play with the extend feature, for example. Okay, let's say I want to extend the edge of this. What I can do is I can hide this one. I can extend this one. Okay, that's the tangent. Let's do the natural. So it's creating basically a circle. Actually, I'm going to finish that. That looks interesting with the aligned edge. Okay, then I can review that. Okay, so I can create complex shapes. Let's extend this. And not this one. Okay, let's extend this perpendicular. Okay, do something like that. Okay, we could also instead of doing an extend here, we could maybe do a ruled surface, not a chain. We have to get rid of the chain, select only this edge, and instead of normal, let's say direction, and select this edge as direction and do something like that. Okay. I hope you guys are seeing the possibilities that this allows, and you can do this by unstitching your forms and controlling each one of the surfaces separately. Okay, so from the modify panel, you know these three from the solid modeling environment: press, pull, fillet, and chamfer, which you can also apply to surfaces. You know the stitch and reverse normal. You know how to split a face. So basically, you know everything under the surface environment. Okay. Now, this is something that you guys can use instead of the modeling environment when you're creating surfaces, when you're creating objects that need multiplications. So you can use offset surfaces, for example, which is very useful. But you have to be aware that to create a solid from these, you need touching surfaces. You need stitched surfaces. First they have to be touching, then they need to be stitched to turn into solids. And we will do an exercise about that in the future. Okay, that's it for this week. I'll see you guys in class.